Welcome, everyone. Thank you for joining us in person and to our Zoom audience. So we're very happy to welcome our guest this evening, who's Dr. Hannah Kirchlow. She is an internationally acclaimed neuroscientist, broadcaster, author, and fellow at Magdalen College at University of Cambridge. Hannah's appeared on a number of things, BBC, ABC, Korean TV and radio, which I saw, very cool. She was recently in the Great Minds series as science presenter in Family Brain Games, Tomorrow's World Live, and BBC Radio 4, Destiny and the Brain. Hannah's written a number of books already. Her book on consciousness, A Ladybird Expert Guide, was published with Penguin in 2018. The Science of Fate, which we also hosted Hannah here for, was published in 2019. I can't believe it's been 3 years already. And that book made the Sunday Times bestseller list, receiving international press coverage. And tonight, she is here to talk about her latest book, Joined Up Thinking, which is just published very recently, last couple weeks actually. So cutting edge stuff that we'll be talking about here. Very briefly to wrap up, Hannah will receive an honorary doctorate from Brunel University for her work in science communication. She's received a number of impressive sounding accolades. In 2019, she was named by Nature as a rising star in life science and recognized as a top 100 UK scientists, and was named as one of Cambridge University's most inspirational and successful women in science. The books are available out in the lobby. And Hannah will be delighted to sign copies of her book. So we'll talk for a little bit. I will turn it over to Hannah. We'll do some question and answers. And I think I'm going to stop talking and turn it over to Hannah now. Welcome, Hannah. Thank you for joining us.
Thank you. Thank you. Thank you so much, Tyler, for that wonderful introduction. And also thank you so much for coming out tonight and braving the wet weather. So we're going to be talking about joined up thinking. So there is no doubt that as a species, we are capable of great things. So if we think about space exploration or some of the inspirational artwork or architecture that's been created by humanity, or if we think about some of the pioneering medical breakthroughs, there is no doubt that humanity can achieve great things. But unfortunately, we also have a dark side. So it's been estimated that somewhere between 150 million and 1 billion people have died as a result of war alone. And we're also facing a number of existential crises now today. So there's issues in terms of geopolitical instability, there's problems with climate change, there's issues of overpopulation and the threat of the next pandemic. So we urgently need all hands on deck in order to address some of these challenges. Only it's not really all hands on deck that we need, is it? What we really need is to better tap into our brain power. So we need to be able to think more creatively, more innovatively, to build consensus, to communicate without conflict, and to start thinking like a good ancestor, so that we have more strategic, longer-term problem-solving skills that we can start making use of. And so this talk and this session with you is going to be exploring how we better access our brain power and how that can affect us as individuals, but also affect how we lead our life and how we build relationship with friends and family and work colleagues, and how those effects might ripple out across society and across generations as well. And this is compelling for a number of reasons. Firstly, because we have so many challenges that we need to start to address, but also because it's thought that as a species, we're undergoing a major evolutionary transition, moving away from the individuality of our past and towards the creation of something that might be more a super-connected organism, a larger group, where we're almost like a hive of bees or a colony of ants. And for the first time in our history, many researchers are saying that actually the value of culture supersedes the value of our genes. And we're being compelled to create these technologies that are helping to spearhead and make this progression in our evolutionary transition. And these are technologies like the communication technologies, like social media, But there are also transportation technologies that are helping us to move across the world and share our perspectives and communicate like never before. But there's also some really interesting developments in neuroengineering. So scientists are looking at ways that we can start to blend our minds together with each of us as humans, but also to blend our minds with artificial intelligence as well. So you might have heard of some of Elon Musk's kind of experiments where he created Gertrude the pig. And you might have seen videos of her having a chip in her brain, and you could read the electrical oscillations in her brain as her snout was exploring the environment around. Elon Musk has also worked with his company Neuralink, creating a monkey that could play video games directly with its mind, the video game Pong. But there's other neuroengineers that may not have such a big platform to talk about their work as Elon Musk, but they're still doing lots of really quite important work that I think as a society we should probably start to discuss. So did you know, for example, that researchers have been able to take a copy of an electronic signature of a memory and take that copy from a donor brain and then imprint it onto a recipient's brain so that thing, that learned thing, that memory, that electrical signature of a memory is primed into a recipient's brain so that individual can start to learn a little bit quicker. Or did you know that we can now, when we look at humans, moving to human studies, we can now hook up different individuals and connect them using electrical signals and magnetic signals so that they can start to work together and problem solve without any other form of communication. And there's other researchers who are working. This is a video that's been created by a guy, Richard Roche, who's a professor at Maynooth University in Ireland, and he's basically creating a 3-person closed loop that contagiously transfers the electrical wavelength that's associated with calm creativity between people. And so he's using a closed loop in order to contagiously transfer emotional states. There's also some other really interesting work that's been done in the science-art sphere. So, for example, there's a couple who are working in the Netherlands that are creating something called empathy ecologies. So they're really interested in how people can connect together and transfer information together. But also, when we look into the wider environment, actually, we're very much embedded within that system. And so what they've done is they've created a system that takes the electrical oscillations of 2 people as they're touching each other. And they're also taking they're measuring the carbon dioxide consumption levels of plants in that environment. And then they're taking that data and transducing it into a musical score so that we can start to hear how the relationship occurs between the physiology of the people and the plants that are photosynthesizing nearby. So this is a video of that science-arts collaboration. You're hearing the music that's been created from that data. So that's just some of the mind-boggling experiments that are occurring within the sphere of neuroengineering. Now, when we're talking about joined-up thinking and brains working together, I had to talk about some of these developments within neuroengineering. And I think they are quite futuristic and startling to some people. And many researchers believe that there is a possibility that if we continue with this type of research, perhaps one day we might be able to create some kind of biological computer that would enlist millions of brains that could be combined so that they could start to pose and answer questions that could otherwise not be addressed by the individual. But perhaps, as startling as these kind of developments might be, perhaps there's other findings from neuroscience that could help us to work together more effectively in order to address some of these challenges that we're facing. Perhaps there's some knowledge that we could have about our brains that could help us to think and act more intelligently. And I really want to look at those more natural ways, rather than those neuroengineering ways, for the rest of this talk. But I also do want to say that I think it is important that society starts to think about how we feel about some of these developments and how we might merge our minds with each other and artificial intelligence, and whether that might raise ethical or privacy or hacking issues into the future. But as we look at more natural ways that we can enhance the way that we think together, I'd like to have a volunteer, somebody that might be willing to join me up here. It's not. I'm not going to be doing anything really, really wacky or dangerous. I promise. So it's literally just peering into someone's brain and reading their brainwaves live on stage. Very brave of you. Thank you so much. Thank you. Big round warm of applause. And if you could help me as well, Tyler, that would be amazing. Thank you. And what's your name?
Louisa.
Louisa. Very brave of you. Thank you very much. So, Louisa, what I have here are some lovely electrodes. There's just 3 electrodes. And move this round. Thank you. Have you ever had your brainwaves read before, Louisa? No. Okay. So this might be an opportunity for your friend to ask you all types of questions. And the answers might be reveal some very interesting things as we look in your brainwaves. Okay. So just putting the electrodes here on Louisa's forehead. So we've got 1 on each side of the forehead, and the third one just going round at the back here. And we're going to be picking up on the electrical oscillations of the 86 billion or so nerve cells that live within Louisa's brain. So we can actually pick up the electrical signals, and if you don't mind holding that just there and keeping that in position, thank you so much. So there's 86 billion nerve cells that are in Louisa's brain, and we're going to be reading or getting a readout from some of those electrical nerve cells oscillating. So what we've got here is a machine that can measure those electrical oscillations. So this green bar here in the middle. Oh, this is beautiful brave waves. Okay, right. Okay, so what you've got here is there a pointer at all with the clicker that I just put down?
Yes.
Yes. Sorry, I should have asked that before. Okay, yes. Where is it? Is that doing it?
I saw it.
Oh, maybe not. Okay. You've got beautiful brainwaves, Louisa. You can't actually see them. If anyone's got a phone and could come up and could put it on like selfie mode so that she could actually see her own brainwaves whilst we're looking at them, that would be fantastic. Okay, so the green waves there in the middle, that's the raw electrical activity of those nerve cells. So those 86 billion nerve cells are connected up to form this massive circuit board of around 86 trillion connections. And if you... Oh, yeah, I can grab your phone if you put your hand there as well, because that's coming off, sorry. Yeah. There you go. So those green waves is the raw electrical activity of those nerve cells, sending potassium and sodium ions pumping in and out of the axon membrane so that you can process all the information from the outside world, try and make sense of it with these electrical signals rushing across that circuit board so that you can instruct your body to then move and also create your thoughts and your emotions. Now, the alpha waves, the blue ones, just ahead of those green ones, those alpha waves are associated with calm creativity. So that's quite a slow, rhythmical kind of frequency of brain waves. Now, what happens when we're a little bit stressed is that that adrenaline, that short burst of adrenaline, can actually be quite good for the brain and help to wake it up, to enhance thought. But a chronic amount of stress can actually activate a brain region that's called the amygdala, that's involved in the threat response, at the expense of another brain region, which is called the anterior cingulate cortex, which is involved more in kind of collaborating with others and horizon scanning and problem solving into the future. So too much stress can basically put the brain kind of activity across the circuits out of kilt so that you're focused on the threat of the here and now rather than thinking about working with other people collectively and creatively into the future. Now, when we're looking at those alpha waves, is there anything that we can do to... oh, look, you're really enhancing your alpha wave activity when I'm talking. Is there anything that we can do to enhance that alpha wave activity other than kind of protecting ourselves from the effects of stress? Well, yes. So it's thought that getting lost in nature can help to enhance those alpha waves activity, which is possibly why, if you've ever got a problem that you really need to solve, if you just take yourself off for a little walk in the woods and kind of relax, or maybe you could just have a bath and have a eureka moment there. You know, that's because the alpha waves are being given the opportunity to burst into activity. So we're seeing a little bit of Louise's alpha wave activity bursting into activity there. Oh, yeah, little burst of it there. So above that is the gamma waves. Now, that's the one in the red. Now, that's the fastest speed of electrical oscillation. So that allows electric signals to zip across the whole brain so that we can basically help joined up thinking across our brain, because we can start to access all of the different bits of information that are spread across all the different regions of our brain so that you have more effectively, more joined up thinking and integrated thought across your whole brain frame. Is there anything that we could do to help boost our gamma waves? Well, yes. It's known that Buddhist monks have wonderfully large gamma waves, and if we try and start meditative practices, then actually that can help boost that gamma wave activity. Now, there's also some really lovely research looking at not just how we can boost our own brain activity, but what happens when we start working with others. And if I was working with Louise now and we were analysing my brain as well as Louise's, what we might see, if we were working together really well and problem solving together really well and working towards a common goal, is that our electrical oscillations would actually start to become synchronised with each other. They'd start to become in step. And when you get a group of people and measure the degree of their brain synchronicity, you can actually use that data to predict how well that group will be able to solve a puzzle. So, if we know that, is there anything that we can do to help boost group cohesion and brain synchronicity? Well, yes, thankfully there is. So, simple things like if we look each other in the eye, then we're more likely to boost brain synchronicity and boost learning. If we do simple things like sing together, then that will also help our brains become in step with each other. And also, if we do exercise, that seems to play a role as well. So perhaps it's not surprising that when we're trying to learn from each other and work together well, we do like to look at each other directly in the eye. And perhaps it's no surprise that there's so many community choirs that are springing up, or that marathons today are so popular, because perhaps we're seeking that brain synchronicity from each other. Perhaps we feel this need for more cohesion within our community, because maybe we know that we need that heading towards that evolutionary transition of a more collective intelligence. Okay, so I want to say thank you so much to Louise for allowing us to read her brainwaves. Incredibly kind of her. Oh, and yeah, brilliant. Thank you. Huge round of applause, please, for Louise. Oh, and I'm going to... these are new ones, and they're so sticky. Was it okay?
Yeah, absolutely.
Yeah. There's another batch of electrodes that I had before that weren't quite so painful to get off. You've still got one on the back of your head. I'll leave you to get that off yeah, because it's so painful. I was practicing earlier today. So there's also some lovely work from Vicky Leong. She used to be here at Cambridge, and she's now based in Singapore. But she's done some work looking at how... she's looking at parent-children dyads and looking at how they interact and how their brains synchronize. And what she's found is that it's not just the eye gaze that's important between the mother or the parent and the child. It's also the parent's emotional state. So if the parent has got depression, if they're not happy, then actually that brain synchronicity and that capacity for learning for the child is impaired. And another thing that she's found, or some of her colleagues have found, is that actually, so some people are more likely to be leading the brain synchronicity for the majority of the time, and sometimes those people that are leaders in terms of brain synchronicity are thought of as more charismatic. But generally speaking, it's a dance. So we take it in turns to lead that brain synchronicity, depending on the stage of the interaction, which is quite interesting, I think. So sometimes the baby was also leading the mothers or the parents into brain synchronicity and interaction. So I want you all now to take part in another experiment that can help us to understand a little bit about how we operate together and how we influence each other's behavior. So for this experiment, I want you to close your eyes, and imagine that you are in a position of ultimate power. Your say is final. You have a huge effect on the world around you. So maybe you are Prime Minister. Maybe you are a judge presiding over an important case. Maybe you are referee on a football match. Whatever situation you want to be in, your decision is final. And hold on to how you feel having that much effect on everyone around you. Hold on to that feeling of power and control. And then I want you to take, with your eyes still closed, take your index finger of the hand that you write with, and I want you to raise it to your forehead, and I want you to trace the letter E on your forehead. Very good. Just remember that sensation of how you've written it. Okay, so remember that sensation. And I now want you to move from a position of power, and I want you instead to think about how the world is affecting you. So I want you to listen to your heartbeat. So, you know, we all have that, maybe we have a gut feeling or we have a flicker of the heart that sends a signal to the brain that tells us, oh gosh, there's something right or there's something that's not quite wrong. That intuition that we have about something. So I want you to spend some time just listening to that heart beating. Listen to it beating. It's taking information in from the outside world. And in fact, there's something like 11 million bytes of data that's coming from the outside world all the time that enters our senses. And we're actually only consciously aware of about 30 to 40 bytes of data per second. So that's a minuscule percentage. But a lot of information and intelligence from the outside world is actually stored within our bodies, within our hearts and within our guts. So listen to that information that's there. And I now want you to again take your finger and write the letter E on your forehead and remember that sensation. And now back in the room. Thank you. So that was really interesting for me, watching you, because what I could see when you were thinking about being in a position of power, the majority of you wrote the E on your forehead the wrong way round in terms of me being able to see it. So you were writing it the right way round for you, but for me, it was a mirror image. So you were writing it like this. Is that right? It's very difficult on stage. So what we see, and what a number of studies have shown, is that when people are in a position of power, or even if they're just simply imagining being in a position of power, they are more likely to act egocentrically. They are less likely to take on board other people's emotional state or their access to different information. And when we look at their biology, what we can see is that they have a decreased vagal nerve activity. So the vagus nerve actually runs from the brain to the heart, and it takes that information from the heart and sends it to the brain, to a region of the brain actually that's called the insula. And being in a position of power actually dampens down the sensitivity and activity of that vagal nerve, so that you're less able, you're kind of blocking out that information from the body. It also seems to dampen down mirror circuits within the brain, which are thought to be involved in empathizing with other people. So it's a fine balancing act, isn't it? Because if you are in a position of power, then perhaps you've got very difficult decisions to make. And so sometimes it can be advantageous to block out some of that intelligence from the world around you and to think about the information that you have solely. But it's never really wise to do that completely. So, is there anything that we can do to help immunize ourselves against this corrupting force of power? Is there anything that we can do to help us to better tap into that intelligence from the world around us and from the cues that people are giving off and from the information that they hold? Well, that kind of leads us into that experiment of listening to our heartbeat. So taking some time to listen to our heartbeat each day. Now, this part of the experiment basically came from a guy called John Coates. He used to be here at Cambridge, but before he was at Cambridge, he used to work on the trading floor in Wall Street. And he was a trader. He made lots of money. He was very, very successful. And so he was scratching his head and thinking, what is it about me that is so successful, that's so amazing? And he thought, I know. What I'll do is I'll come to Cambridge and I'll retrain in neuroscience, which is how I met him. And what he found out in an admittedly small study was that those traders that made more money were actually better at detecting their heartbeat. And even more than that, their heartbeat detection ability actually predicted their trading profits during a period of economic instability. So it seems as though being able to tap into that intelligence that's stored within our body, that comes from cues of people around us, whether it's on the trading floor or whether it's, in the restaurant or the canteen or the committee meeting room, or the conference centre, or at the school gates with other parents, being able to tap into that information more effectively so that it affects your decision-making without you really being consciously aware, seems to help your own intelligence, and that can actually turn out to affect even your financial kind of situation, which I think is quite interesting. So Sarah Garfinkel, she's a professor at University College now, and she's been looking at ways that we can all start to better balance our intuition and our interoceptive ability and the way that we pick up information from the outside world. And so again, she's looking at ways that we could just, listen to our heartbeat each day and spend some time doing that. Now, I find it really actually quite difficult listening to my own heartbeat. So what I have to do is, and I'm also not very rich, so what I have to do is do star jumps or running on the spot a little bit before that exercise to kind of get it beating a little bit stronger. Is there anything else? Oh yeah, so this is the tapping into our superpower intuition kind of study. So this is the insular brain region here that's involved in picking up those signals from our heart. And there's differences in activity from those people that are super intuitive, that are super able to tap into that data. So is there anything else that we could use, any knowledge from neuroscience, to help us to think more effectively? Well, yes, there is. So we're currently living during a genomics revolution, and we know that the 3.2 billion base pairs of DNA that we're given from our mum and our dad that creates us as a person, or helps to lay down the foundation of our biology as a person, well, a lot of those genes, I think it's something in the region of 30% of them, are actually expressed in the brain. And those differences in the genes that we've got from our mum and dad, the variation that exists within our species, and the ways that those genes uniquely combine and change shape in us as an individual, can then affect how that neural circuit is laid down when we're a baby in the womb. And there's lots of studies that are showing that the genes that we're given from our mum and dad go on to affect not just our height or our weight or our eye colour, but also really complex behavioural traits as well, like longevity, our religiosity, our ideology, even our intelligence, even how impulsive we might be, or maybe even how extrovert we might be. There's many different, very complex behaviours which have a biological underpinning in some part. And because of the breadth of the DNA that we've got, these 3.2 billion base pairs, and the way that they can be combined in different ways, and the way that they then go on to affect our neural circuitry, and then also our very complex behaviours, you can start to see that actually it makes sense to have a really diverse team within your kind of area. So we each of us have strengths, but we each of us have slight flaws or idiosyncrasies, if you like, with our behaviour. And perhaps it makes sense to make sure that we recruit a team that's very diverse. And I'm not just talking about genetic diversity, I'm also talking about environmental or cultural diversity as well. Because as we go through life, it's not just that everything is set in stone because of the genes that our mum and dad have given us, but our brains literally change in response to the environment. They're able to learn from the things that surround us and remember that learned thing so that we start to see the world in a new way, so that we start to integrate information from the world around us into our current template of the world. And that goes on to affect us in many ways. And that's through this kind of phenomenon called brain plasticity, that means that new connections can form throughout our life. So there's a lovely example of how Richard Gregory is wonderful. There's a lovely example, however, of how, I've gone a bit too early to that slide, so it's going to cut off, I'm a bit worried. There's a lovely example, however, to how amazing as our brains are, with these huge number of genes helping to create the way that our neural circuits are laid down as a baby in the womb, and how our brains can change throughout our life. As sophisticated and intricate as that system is, it also actually has some flaws in its design. Because in order to create an up-to-date sense of reality about the world around us, our brain has to take many shortcuts in its information processing. And it does that as a result of our experiences. So, for example, I'll go on to this now. This is a rotating mask going round and round. And as we get to the back end of the mask, the eyes and the nose are poking backwards, and the shadow information is telling us that the eyes and nose are going that way. But our brains, because we're so used to seeing information and faces from the world around us, just ignore that shadow information and just sees another face popping out. So this is a consensus in how all of our brains, because all of us so used to seeing faces from the environment, that all of our brains make this error in our information processing. So that's common across the human species. But if we go to this illusion now, so if you have a listen to this file, and now if you listen to this file. So that was probably gobbledygook, right? Very quiet gobbledygook, but listen to this one now.
Camel was kept in a cage at the zoo.
And now we're going to go back to the original. So suddenly, your brain overlaid the sense of the camel was kept in the cage at the zoo onto the gobbledygook sentence, and you were able to make sense of it. And now, forevermore, whenever you hear that gobbledygook sentence, you will hear the camel was kept at the cage of the zoo. You won't be able to stop yourself. So that's an example of how our brain takes on board new information and affects how we view reality. And so you can start to see that all of the different experiences that we have throughout our lives, some of them common to other people, but some of them different to other people, actually affect how we think and then how we might interact with the world. Which is why, because of our genes and because of our experiences, it makes sense to make sure that you work in a diverse team. So that you can start to tap into the different ways of thinking and the different errors and strengths that all of those different brains offer. So make sure that you identify cognitive diversity in your team if you're starting to recruit a team of people to work with. Think about genes. So, for example, many software companies are now doing recruitment programming kind of special services where they're really trying to recruit people with autism, for example, because they know that they're very good, typically, at focus and attention to detail. Or people with ADHD, again, another condition which has got a high genetic background, is associated with particular traits that can be incredibly useful to businesses. So make sure that you've got genetic diversity within the team. Also experience diversity. So make sure that the people that you are working with, or when you're trying to think and create some kind of plan or problem solve together, make sure that the people that you're talking to, looking for answers, might have different experience diversity, but also age diversity, because we know that as we go through our lifespan, our brains change and have different strengths. So, for example, the younger brain has much more plasticity, so it can think much more laterally and much more creatively, generally speaking. My brain, not so creative, not so lateral. In fact, if you look at my brain under a microscope, you'd also see that it's slightly withered and died, and which is not so good. But I will have accrued a bit more wisdom and expertise in particular areas. So in some ways of thinking, my brain processing will be slightly faster. When we look at much older people, what we see is that, again, they've accrued that wisdom throughout life, and so they're able to think much more quickly within their area of expertise based on their wisdom and their experience. It's also important when you've got a group of people to make sure that you avoid dominance dynamics. So there's simple things that you can do, for example, flipping hierarchies within a group, so making sure that the most junior person speaks first or leads a team. Also, little things like brain writing, so writing down ideas rather than verbally contributing them to the group can actually generate twice as many ideas, and the ideas are valued to be better as well, be of higher quality. There's also some work looking at how if you spread expertise within a group, then you're more likely to obtain success. And in fact, there was an incredible analysis of something in the region of 20 million scientific publications recently and over 2 million patents. And what they found was the winning formula for success. It was actually making sure that you had a high number of people within the team that had a really unusual combination of expertise. So, for example, they brought together people that had a background in anatomy, those with computer science, those with engineering, those from the humanities, and those from AI, and those from history. So bringing together different types of backgrounds, different types of expertise can actually help create scientific publications that have higher impact and have a higher citation factor. But sometimes, when you're working in groups, it can actually be quite difficult. I'm sure we've all experienced, a really unagreeable committee meeting, or trying to find out where we should go for dinner with our friends, for example, and nobody can agree, and then you just end up wandering around until the majority of the restaurants are shut. Or maybe you're trying to find, as a group, trying to decide where on the beach you should sit down, and then you end up traipsing for quite a long time before you just finally just sit down anywhere because you give up. So sometimes it can be quite difficult to work as a group. So is there anything that we can do to help with that, other than helping to boost brain synchronicity, for example, being aware of how power can corrupt, and starting to immunize ourselves and make sure that we tap into our introspection? Well, yes, there is. And for this last kind of section of the talk, I want another volunteer, so somebody who doesn't have a heart condition, preferably. It's a bit of a mean experiment. Is there any volunteer? Any? Oh, but very kind. Thank you. Thank you. Please join. Yes, big round of applause. Hello. So, yes, please sit. So, what I have here, what's your name for everybody?
Rosie.
Rosie. I do actually know Rosie from a school pickup. It's nice to see you, Rosie. Okay, so what I have here, Rosie, my friend, who I'm going to have to see probably every day for the next 5 years, what I have here, Rosie, is an electric shock panel. So that's a bit awkward, isn't it? Yeah. So what we're doing is we're playing with uncertainty. Because whenever you're in a group, right, people have got a different viewpoint from you. Because of the way that their brains operate, they are going to think slightly differently from you. And sometimes that can be quite difficult to deal with, especially if you have a particular viewpoint. To change that viewpoint and to try and compromise or think in a different way actually requires quite widespread, or it can require quite widespread demolition work of some of that circuitry and then some rebuilding work. So it's really difficult. It's like, going to the gym for a really hard workout. But sometimes what we need to do in order to engage with that process, rather than to just simply interact with the people that agree with everything that we think, which can be tempting, actually what we need to do is we need to increase our tolerance for ambiguity and uncertainty. So we need to kind of think of interactions as fun and be curious about other people's viewpoints, rather than to find it difficult. And there's some really lovely work that's going up in Newcastle. There's a lovely researcher called Layla Moffat there that I've been speaking with. And she's been doing some really nice things with people, like playing games of Jenga in order to increase their tolerance for ambiguity. But what I'm going to be doing is applying an electric shock to Rosie. Sorry. So Rosie, what we're going to do is we're going to apply it here. So just think at how this is going to help your joined-up thinking and your collective intelligence, because you're just welcoming these new experiences here and kind of being curious about it.
We have ethical clearance for this, right?
Yeah, we do. Yeah, totally do. Totally do. Are you feeling uncomfortable now?
No.
Okay, good.
Go blame the other people.
Yeah, just a tiny bit. Okay, all right. So I'm going to press start. Can you feel it?
Yeah.
Okay, and then we can there we go. There we go. Yeah, so there we go. And I can, would you like me to increase it?
I mean, you can.
There we go, it's going off and then on.
Okay.
And then there we go. You have increased your tolerance for ambiguity and uncertainty. Because we're living in a time where, we've got Google Maps on our phone. We've got quite a lot of our lives structured and kind of is known territory in a lot of ways, with our lives. But then also there's quite a lot of larger scale instability and uncertainty, things that we can't control. And particularly for younger people who are growing up with Google Maps on their phone, with a Google Calendar, with all of these kind of ways that chart the world around them, there's not a huge amount of uncertainty in terms of their day-to-day life in some ways. And so actually we really need to make sure that we all still embrace ambiguity and uncertainty. And we need that for our joined-up thinking and our collective intelligence. So thank you very much, Rosie, for helping collective intelligence in that way. Thank you. And with that, I do believe I'm finished, so it's open to questions. Thank you very much. Yeah.
Just an observation. I living in London a long time, and I came to start an NGO which was inventing something new.
Microwave?
Sorry, I
microphone?
should- yeah.
Just living in London a long time after growing up in Australia, and I came to having to create with others an NGO, and we were inventing something new. And it was almost as if I knew I loved diversity in London, but it was almost as if I subconsciously understood it was really important to have a very diverse group to create this new model and this new idea. And it actually became really critical to what we were doing. So there was something almost subconscious that picked up this need for diversity. And it was just absorbing living in, seeing every day in London and realising one of the things I love about London the most is its diversity. And I just wondered if you had any comment about it.
Yeah. So it's really interesting. Robin Dunbar, who's anthropologist at Oxford University, has got this theory that we basically wander around with almost like a barcode that's scannable on our foreheads, that kind of, and we generally speaking, we look for people to be friends with that are quite similar to us in terms of our temperament and our background and our experiences growing up. And the reason for this, in some ways, is because then it's actually easier to relate to them, right? Because they've had the same or similar experiences. And so in order to communicate with them, it's just that bit easier because you kind of get each other. But also, competing with that, within each of us, is this requirement for novelty and for stimulation and for newness. And some people seem to have greater balance, so they're skewed towards seeking out more novelty and more and like more diversity and more difference, and find that more interesting than others.
And a quick note to mention that question and answers are also available for people on Zoom right now. So feel free to use the Q&A on Zoom and we'll get to some of your questions. Any other questions in person? I'm going to read some of these and summarize. Questions over here.
But what worries me is that committees are not known for creativity. I'm an entrepreneurial businessman and I hate teams. I hate team games at school.
Yes.
Two other things. Power Corrupts was written by Lord Acton to my great-uncle. He didn't actually say that, but it was almost what he said. I've got the letter somewhere. Isn't that amazing? And lastly, Richard Gregory was the nicest man I've ever met.
Oh, yeah, he's wonderful, wasn't he?
Yeah,
he's so wonderful.
Yes.
Yeah, really, really lovely person.
He came to my company and he said, you should put your coffee machine on free dispense. If you work out how long it takes him to get the right change, you're saving money by just giving him coffee.
Oh.
Bless him.
Yeah, bless him. Yeah, he was wonderful. I think
Teams.
Teams. In terms of committees, but the idea of a lone genius isn't correct, is it? Because you never conjure up new ideas all by yourself. You still. No. I mean, well, you're in a quite powerful position, aren't you? You might think that, maybe, because there's some vagal nerve activity that's kind of, I don't know, yeah. But generally speaking, when we look.
It worries me about socialism coming in. You end up like Cuba, they're all joined up and working together. It's a big disaster, Venezuela, disaster. You want individual entrepreneurs breaking things up, smacking things up.
Well, and there is a chapter within the book, which I'm very delighted that you've got, which is all about the requirement for leaders, actually. So I'm saying, leaders can be corrupt, but actually there is a requirement for leaders because, if we just look at the kind of humankind being able to start running the mile in under 3 minutes or 4 minutes, was it? Yeah. So originally it was thought that it was completely and utterly impossible. And then this guy in Oxford just happened to just do it at some mini little race on a rainy day across the cobbled streets. And he managed to beat this kind of big goal that had been set but had been thought was incredibly impossible. And people had been trying to achieve it for many, many, many decades and hadn't. So he managed to do it. And then in very quick succession, many other people around the world suddenly were able to do it. So we need leaders to help show the way, to help change the psyche and change the expectation of what is possible for our species. But the good leaders are there, and you know, and I'm saying this in a way that makes me sound, what's the word? It makes me sound not great, and I'm aware of that, but good leaders will basically be really good at harvesting the data and the intelligence from everyone around them and tapping into that and then just gathering it up in a way that makes sense so that they can actually lead and innovate in a new way. And destroying, changing the expectation, of what's possible. Evolving, that's it, exactly, evolving. So going back to, so Isaac Newton, for example, he's thought of as this typical lone genius, but actually it's no surprise, really, that he studied here at Cambridge, and the whole concept of these Cambridge colleges is ensuring that we've got a system that allows people from different expertise, people that are training in different areas, to come together to talk so that you can start bringing different viewpoints together so that actually it enhances everybody's brain power.
We have let me do one Zoom question first from online, if you don't mind. Garth, thank you for all your questions. Related to this question for you, Hannah, how can we ensure that we have a sufficiently diverse team? Do helpful thoughts get weighted more heavily than unhelpful ones? How do you judge what is useful overall when you're thinking about what you were saying in terms of diversity in thought and work in a group?
So how do you make sure that you
have a sufficiently diverse team when it comes to thinking?
Well, you make sure that you're recruiting, looking at age, making sure that you're not just picking lots of people that are from one or two universities that are known for being really good, because even though those people might have come from different parts of the world and might be genetically different or, whatever, they've actually been taught by the same people. And so their way of thinking will be quite similar. So trying to widen your recruitment kind of strategy. And then how do you make sure that you're selecting the good ideas? Oh, that's a bit common sense, isn't it?
Yeah.
I think that's having a good leader that can then make those decisions.
Okay.
And has a clear goal. What's the point of this? And then is able to evaluate each one of the ideas that pop up with that goal in mind.
It reminds me a little bit of what I think it's Amazon. I think how they run meetings, and I think this is in your book too, or it was another book I just read. But about like how they kind of structure their meetings in terms of everyone is allowed to.
Yes.
That was your book, of course.
Yeah.
Yeah.
They have a minute of silence.
Yeah.
So they have, So they go to the meeting and they read the document that's kind of putting together what the issues are that need to be addressed and what some of the ideas might be for it. And then before anyone starts discussing, they just sit and think for a minute or two, or sometimes even half an hour, I think, before anybody speaks. And then the most junior person speaks first. So really, the art of listening is quite good, or trying to absorb information rather than just trying to contribute. And I think maybe we need to, particularly within the UK, I think we need to, from a very young age, instill in children, and I'm saying children of both genders, and I'm going to come on to why I'm saying that in a bit, that actually we need to listen to each other a bit more. And you need to start, instead of ranking children by achievement, actually start trying to get them to work together creatively from a very young age within the educational curriculum. And the reason that I talked about gender earlier is because there's massive studies that have been undertaken by Anita Woolley, who's based over in America, and she collaborates with Thomas Malone, who's at MIT. And what they've done is they've done lots of different studies looking at collective intelligence and how groups work together, trying to find out what is the recipe for success. How do you find a group that can work together really well and problem solve and reach a goal that's been set? And they found that there's one thing that can predict how successful a team will be. And it's not the IQ scores of the individual members. That's not the thing that's important. Actually, what's the most significant predictor for group success is gender ratio. So the higher the number of females within a group, the better that group will do. And it's not, the women are clacking here. And it's not because there's something on the Y chromosome that makes males inherently a little bit thick. It's just, I don't think, although Anita has sent me some emails disputing that actually possibly is. But no, but what generally is, what they have shown is that it's linked to turn-taking and listening. So females, because they are possibly socially more expected to listen and to turn-take, are able to harvest information from that group more effectively. And so they're able to better innovate and problem solve. And I don't think that boys are not able to turn, take, and listen, but I think it's a skill that should be encouraged from boys at a young age. And it's not what I see happening at the moment.
We had a question, gentleman in the second row, and then, well, we'll do you next. Yeah.
I love the point about the sort of hierarchy of age, that perhaps traditional societies, the elders were in charge and knew everything. And that the learning is that actually that isn't necessarily right. So I wonder, you mentioned in a group the idea of getting the youngest person to speak first, which I think is great. I wonder what other mechanisms you might advise for groups to embrace gender diversity. And also an allied theme in terms of people more of my age being mentored by the 20 and 30 somethings. And my learning to receive that rather than the world I grew up in, which taught me that the elders knew best. How do I facilitate better learning by my 30-something mentors? Thank you.
Thank you. That was a really good point. So there's quite a lot of organisations now that are recruiting younger interns as well as older consultants within a team. And then, sorry, what was the other part of your question? That was.
So there were two parts. How do organisations learning? How do groups learn? What mechanisms can groups use to build the voice of the younger ones in perhaps through process? You mentioned getting the younger person to speak first, and secondly, in one's individual life, being mentored by my younger friends. And two of my younger friends who are in the are taking to me to Austria for a week in 2 weeks' time, and they are brilliant mentors. But there's a part of me that resists and says that you shouldn't need to be mentored at your age. Come on, you should be telling them what's right. So, yeah, how do I combat that? How do organisations build in the young voice and accept it and learn to work with that and make that their normal way of thinking? And how do we as individuals do that?
Yeah. So Lord Rees has set up an all-party parliamentary group, specifically with younger people that are going into Westminster to try and talk about their views, which might be slightly longer term because they're thinking about how their lives are going to evolve over their lifespan, which obviously there's many more years left of. So there's routes like that, making sure that there is a group where the younger people actually have a route through which to have their voice listened to. I think creating a culture where we appreciate every different person's point of view, and everybody gets to have a say. And and we're creating that by the technologies that have been created through social media, through through many different routes, which now allow lots of people to contribute to the discussion that's being had. Which is why it's thought that we're going through this evolutionary transition towards having a greater appreciation for this diversity. If we look at the success of Wikipedia, for example, where you can see that everybody is contributing and it's created this vast wealth of knowledge that's constantly evolving and is owned in some way by all of us, particularly if you donate to it. But in terms of making sure I think it's a culture change. I think it's, you know, we are at a point where we are going to be appreciating younger people more and thinking about how they can play a role in society, rather than just be kind of shushed and told to comply. Actually, they usually have the more creative, innovative ideas. Some of them are creative and innovative and just entirely wacky, so should be discarded, but they are, generally speaking, they're able to generate more ideas, and some of those ideas will be absolutely fantastic. And so, you know, we need the older people as well to work alongside the younger people so that we can start using that wisdom to sieve through the ideas that are being generated by all these different brains. So I think it's a cultural change, and I think that's coming.
We have time for a few more questions. First in the front row, and then back row, and then over here. Thank you, everyone, for waiting.
Hi, firstly, thank you, Hannah, for a lovely talk and a lovely evening. These are probably two observations as much as questions, and take a deep breath. I'm very, very good friends with Tim Schmidt, who started the Eden Project, and I think you should watch his talks, because he has done organically, without knowing much of what you've talked about tonight. So when he started Eden, he was winging it, he hadn't got a clue, he was literally done a wing and a prayer, and he said he made his decisions by intuition. And he's a real mentor to me. And one of the things you have to do when you join Eden is go for dinner and get drunk in the pub, and that's when you have your induction. And you relax, and he said we talk about their business meetings are held over breaking a pizza. So much of what you said, he did, and he's done over the last 20 years. Having said that, he's also a phenomenally successful capitalist, and he hosted the G7. So on the one hand, it's sort of out there a bit, nuts and nut cutlets and sandals, but he's equally probably the greatest entrepreneur we have in this country. But he's done everything you've talked about without knowing he's done it. So I'd love to put you in touch, and you should dissect his talks, because one of the opening things you said, he wants to create an AI otter to go through our rivers, to bring back automatic feedback of the state of our rivers, but equally a fun toy for kids to buy. So you can go and spend 15 quid in Amazon, buy your child an AI otter, and then whack it in the sea. And, you know, he's just got this, he does intuitively what you're talking about. Mm-hmm. So I think he's one of the most fascinating people alive.
Well, this is it. Neuroscience really, you know, I don't think we have to use neuroscience for these neuroengineering things. I think actually neuroscience can be used to just basically tell us stuff that we already really kind of know, and just to back it up so that it prompts us to behave in a slightly better way.
Second point I'm going to make, and then I will go. I've got friends who are very senior in the army, both ex and current, and talking about organisms, and whether or not you're a royalist or not, watching the Queen's funeral and the mechanisms of a huge body, completely disparate backgrounds, all nations, all cultures, all educational backgrounds, having, yes, gone through a certain system, but I've got friends and they have taught me various protocols, and that works. It's been working for 600 years. So I was looking at that thinking, whatever you might think and whatever one's, you know, perception of what's going on,
they were united through the collective grief.
Well, like ants, the mechanism of how the thing worked, it was an organism working as one.
Yeah, and there's some really interesting work looking at also how emotions are contagiously transmitted between or across people, and this can be in person. So, for example, if I'm frightened, in my sweat there'll be a particular chemical which you might not be consciously aware of, but will subliminally signal that I'm in a state of threat, and so you should be ready in case that threat might come and attack you as well. But this also works online. So in a questionable study in terms of ethics, there was a few years ago, there was a study that was published in PNAS, and they basically manipulated over 600,000 Facebook users' news feeds so that it was either skewed towards positive news or negative news. And what they found was that the majority of people then started to mirror their feeds that they were seeing in terms of their content. So if they were seeing more negatively skewed stuff, they were then posting more negatively skewed stuff. And so they were amplifying that emotion. They were transmitting it and amplifying it across their own feeds. So emotionally, we do transmit and we do contagiously kind of pass on emotions from one person to another. So there's a lovely other study as well that shows that if your neighbor is happy, that increases the probability that you'll be happy by something in the region of 25%. So that's quite nice. And if your best friend is happy or your sister is happy and you live relatively close to each other, again, it increases your probability that you'll also be happy by around 30%.
He said that when you make a decision to do something, there's a change in your body language. So if you decide, well, I'm going to do this, I'm going to crack on.
Yeah.
You go to a meeting and he's convinced that your physiology changes.
Yeah.
And you're more likely to convince the person that you've got to convince. He says literally sort of becomes physical.
Yeah, absolutely. Oh, yeah, absolutely, because you're being more assertive, you know, you're being more determined, you know exactly what you're doing, you know what your goal is. But it's not just emotions that can be contagiously transmitted, it's also moral values. So by simply interacting with a person, my moral values will start to veer unconsciously towards yours. So it's quite important to think about how we all affect each other and how we all work together.
Time for 2 more questions, Hannah, in person, and then 1 online, if that's all right. So we got a woman in the back. I think we should use that microphone. I'm not 100% sure the other one worked. And
Hi. So you already touched on the point of the role of digital technology, and actually I would like to hear from you your thinking about, do you think digital technology as we see it now developing is more a barrier or enabler of us becoming more sensitive to basically information from other people and learning from it and becoming more open? Or do you see it actually us becoming more individualist because we are locked in the information we are actually receiving and it's targeted?
Yeah, that's a really good question. So originally when I went on Facebook a while ago, how long ago? Geez. I loved it because it offered up new opinions, you know, not just The Guardian or The Times or whatever newspapers that I was reading or whatever friends I had in my vicinity. It offered many new different ways of thinking. Because people were posting and sharing so much more. But now there seems to be the algorithms that are just closing everything down, so that actually it's narrowing that. So that breadth that I was seeing has just been kind of curtailed, which I'm not very happy about. But I suppose that's why you've also got things like Twitter or Instagram. I think one thing that we've got to consider is that we're all curators of the feeds that we subscribe to or create. So actually it's kind of up to us to make sure that we are, so for example, I follow quite a lot of groups that I really don't agree with. Like politically, ideologically, some of their ideas actually repulse me. But I follow them because I want to know what they're saying. I want to know what other viewpoints are out there, because there's always some reason or there's something behind that. And so I think having that curiosity can be useful. And then there's the other point that, so I think social media is fantastic in a lot of ways because it helps a lot of people that might not otherwise have a voice actually share their perspectives. I think we're going through kind of almost like a teething stage with social media, which is why there's been so many issues with it. And I think it's going to require global mandates to deal with it, actually. I think that's going to be quite interesting to see how that evolves. So more international law to help with the issues of social media. And I think that those international laws could actually help unite us as well. So, it could be a really positive force. But then The Guardian did describe me as determinedly optimistic. So I don't know. There's a really interesting, Molly Crockett, who's at Yale University, has done some really interesting work on moral values, but also on outrage and how it's so much easier to kind of articulate your outrage online rather than in person, and to be mean to people with that outrage. But she argues that this outrage, some people think that outrage can be useful because it can galvanize kind of a revolution, or it can make people act. But she argues that actually some of this online outrage is just nasty with no real purpose, and it numbs a lot of us and actually makes us more apathetic. So I think then there needs to be some international regulation on the way that social media is used. And it was really interesting to see how, I think it was Australia and New Zealand brought in a new law in response to the massacre that was occurring in Christchurch, I think it was, and that being kind of filmed and made available online. So there's a new law that's been passed within those Antipodean countries there as a result of that. And I think that there needs to be more regulations like that come into force, but done on an international level.
And then question over here on this side. Thank you for waiting.
Thank you. I have a question, please, about the physical basis of genius. Let's suppose we had two people. One is a world chess champion and the other is not. And we sent them along to a scientist who was not allowed to talk to them, but was allowed to medically examine them using the most modern tools such as MRI scanning. Would the scientist be able to identify which is the world chess champion?
Ooh. Strategy.
Excuse me, sorry.
Ah.
Perhaps I could just enlarge it. If we talked about something physical rather than mental,
Yeah.
if one person is a boxing champion and the other is an ordinary mortal, and you sent them along to the doctor and he did the examination, he'd be able to tell which is which. But my question is, if it's a mental difference, are our tools of studying the brain capable of distinguishing which is which?
Yeah. I don't think we're at that level, that resolution of understanding at the moment. Yeah.
Can I assure you, as a former British chess champion, that they couldn't just tell the difference?
There we go. I don't think we're at that. I don't think we're at that level of understanding about the brain and behaviour yet.
But even, I mean, do highly intelligent people have bigger parts of certain parts of their brain? I mean, is there any physical relationship? No.
There's
So
that London taxi cab example.
there's the London cabbie drivers. Yeah, but that's particular traits, though, isn't it?
Yeah.
So not chess, like not strategy.
Yeah,
I don't think I haven't heard anything on strategy. So London taxi drivers that are really good at navigating and memorising their route, they've got slightly bigger hippocampi, particular area of the hippocampi, and that builds up and expands as they do their training. But I don't think they've done that on chess players.
There's some logical tests that chess players do well at,
Yes.
others that they don't.
Interesting question. Good research study for anyone out there here or listening online. I'm going to try to summarize a couple of these online questions, Hannah, if you don't mind, and I think we'll wrap up. If anyone has pressing questions, we can do a short question, no comments, just like short question sort of things. We'll try to fit you in. Neil, thank you for sharing your questions here. So many of us work in very technical task projects and need a common knowledge to understand what is being discussed or worked on, which predisposes a certain amount of common previous experience. How do we maximize diversity in that situation? I think that ties in with some of the things we've talked about in this room a little bit.
Yeah, so that's making sure that you have access to people that have different areas of expertise and different
Yeah.
backgrounds, and that you know who to go to as well
Yeah.
for particular bits of advice that you need.
And then I guess to follow up with that on your example of the patents and scientific citations and everything, knowing that diversity in all of these different areas of expertise, how do we make that fit exactly? Is that enough in itself to just bring together all kinds of people who know different things, or from a leadership perspective or a management perspective or whatever we want to call this, like how do we do that then? Or is it simply enough to just bring them together and then?
No, because then you need to make sure that you've got the tools so that they can communicate with each other without the dominant dynamics interfering, so that they don't just create like an echo chamber clone-like viewpoint. So yeah, again, it's the communication experience, making sure that every person feels confident in their own area of expertise that they're representing. So if it's very clear to everybody, you are here as an expert from this area, and you're contributing from that dynamic. You can veer off if you want, but that's generally the area that you're coming from. And people feel confident in that. And then making sure also that you've got a way that you can aggregate all of that information and collate it once you can.
Okay.
Yeah.
Great. Any last questions from anyone? Yeah, we can fit in one more. Woman in the back here.
I've got two daughters, one of whom is 17, and watching her grow up with the stimulation on the one hand from the internet, TikTok, all the social media sort of side of things. So she's, obviously, as all teenagers are very connected into what the world is thinking. But on the other hand, teenagers these days don't seem to have much time for the of silence. You were talking earlier about just actually being silent and allowing your brain to develop ideas. Do you have any thoughts about the sort of dichotomy that they're growing up in, please?
Yeah, I think at the moment we're kind of living in an era that's veering more towards us focusing on immediate gratification and feeding that rewards circuit insatiably. So we've all got an evolutionary embedded reward circuit that's within our brain that helps us stay motivated and keeps us behaving in particular ways. And originally, way back on the savannah, that reward circuit was there to make sure that we could be bothered to go and get food, to go and hunt food or to forage for food or to go and find some water so that we could survive. But lots of different things hijack that reward circuit, including, sugary treats, but also, sex, but also lots of different things that we all enjoy within life that we're motivated towards. They can cause us to have compulsive behavior towards things. And actually what we need to do is make some time so that we can balance out that reward circuit with other circuits within our brain that might be more tuned to thinking about the wider perspective or society at large or longer term thinking into the future. So it's making space to balance the circuits in the brain, and that happens through exercising. So what I mean by exercising is by taking the time to think in other ways and to do different activities so that you're starting to keep things in balance, if that makes sense.
I think that's a good note for us to kind of wrap things up. And speaking of social media, for those of you that have questions online and in person, you can follow Hannah on the Facebook or the Twitter or the Instagram for more information or if you want to reach her. Hannah, you'll be signing books outside in the lobby. Books are for sale, so if anyone would like to get a physical copy, chat with Hannah a little bit more, we'll be available just after this. One final question for you, Hannah. How much for the Brainwave machine? How much do one of these cost if we want to measure our gamma waves? And how much for the electric shock thingy?
It's about £10,000.
Okay, yeah.
Yeah. So on my introduction slide, it's AD Instruments. They're a great company, and they've very kindly donated me the bit of kit, but be careful with it.
Yeah.
I try not to keep water too close to it. Yeah,
Okay.
with the software and all the add-ons and everything for it, about £10,000.
Okay.
Yeah.
Check on eBay after this.
Yeah.
All right. Okay. Thank you, Hannah. Thank you, everyone, for coming.